Stump the Pump Guys Facebook Live event. I am Lisa Jafar, Senior Order Administrator for Waterous, and I will be your host. A little background on what we'll be doing today. Waterous sent out a request via email, Facebook, and Instagram a few weeks ago asking you to send in questions that our esteemed panel will try to answer. Oh, these aren't my glasses. Maybe it is. The panel consists of 3 Waterous experts with over 110 years experience. They have not seen or heard the questions ahead of time, so we will see if we can stump the pump guys. Oh, we have our first question. Why do we call it Stump the Pump Guys? Well, many in the industry consider Waterous the pump guys because that's all we do. We don't sell apparatus, we don't sell gear, we make pumps. So we are the pump guys. So let's meet them. Let's start with you, Jay Rott.
Good afternoon. I'm Jay Rott, Senior Service and Technical Specialist. I've been with Waterous just over 40 years.
Good afternoon, everybody. I'm Steve Moreland. I'm the Customer Service Manager here at Waterous Company, and I started here 41 years ago.
And I'm Greg Geske, the Global Director of Sales and Marketing. I'm the young one. I've only been here 30 years.
Thank you. Well, now let's get to the questions. Question 1 we have from Jeremiah from Fairbanks, Alaska. Is there an effective way to determine if the wear ring gap is excessive without disassembly? Who would like to answer?
I'll take it.
All right.
So, good question. Excessive gap between the impeller hub and the wear rings can result in 2 problems. Both should be noticed at pump test. Primarily, the gap is there to improve drafting capabilities. So, if you're not able to pump rated capacity from draft when you're doing your annual pump tests, that's one good indication that the problem may be excessive gap between the wear ring and the impeller. The other thing that the wear ring does is it prevents recirculation inside the pump. It prevents the water from going from pump discharge back to pump intake through the wear ring impeller interface. So if the gap starts to enlarge over time, you're going to have more bypass there. The result will be when you're doing your pump test, you will have to spin the pump faster in order to pump the desired amount of water. That's one reason why if you do annual pump tests and you keep records of those pump tests from year to year, you may know, assuming that the test conditions have stayed the same, you may notice that the speed required in order to pump rated capacity every year goes up slightly. And that's probably one of the biggest reasons why, because that area is wearing. So it's important to save those records every year because when the day comes, or if the day comes where the pump won't pass test, it's important to be able to look back to those past results to determine if there's a pattern. And if there is, that's a good indication that may be the problem. Waterous does do some things to help prevent that from happening because that is a crucial point as far as performance goes inside that fire pump. We use different designs of wear rings on different impellers to help reduce the bypass and the flow through that area. And although we can't shut it off completely, we do offer flame-plated impellers on our fire pumps, which will reduce the effects of the abrasives in the water that is passing through that area from wearing the impeller hub. But good question, Jeremiah.
All right, question 2. Ben from Spring Valley, New York. He says, why do some pumps have a recirculate/cool pump valve while others don't? He said, I was taught to open the tank to pump valve and idle the pump when we are not actively using water.
I guess I'll take this one.
Greg?
During the pump operation training, which we do, anytime we engage the pump, we want to be moving water. The reason for that is water that's deadheaded that comes from our tank and doesn't go back to tank or out to any discharges will heat up over time. and that will cause the water to get hot enough that it could cause damage to anybody that gets that water on their skin. So we worry about, number one, protecting the firefighter. So we never want to deadhead water. We want to keep that water moving. The second reason, if it got hot enough, it's hard on mechanical seals and other parts that are in the pump also. So you always want to open up, recirculate water, but most of the manufacturers have gone away from what we used to have as a pump cooler line or a recirculation line that was typically 3/8 or a 1/2 inch, and they've incorporated that now into the tank fill valve. So you want to crack the tank fill valve, and that's the important part, is just cracking it. A lot of times that's a 2-inch valve, and a 2-inch opening flowing at 60 psi is going to want to flow about 1,250 gallons per minute. So if you're operating from tank, at that point you would be trying to cavitate your pump and returning too much water to the tank. So the reason we've gone away from the pump cooling line is the OEMs have, a lot of them have gone to the tank fill, and it's usually tank fill / pump cooling.
All right. We'll go on to question number 3. Ron from Artesia, New Mexico asks, my question is, what are the 3 major units that comprise the water's pressure control system?
I can take that one.
All right, Jay?
Basically, there are 2 systems. You have a discharge relief valve system, and you have an intake relief valve system. The discharge relief valve system will control discharge pressure, so you don't have an overpressurization of a discharge line. If you're running 3 hand lines, you shut 2 of them down without a relief valve system in place. One line could be overpressurized, and it's firefighter safety. You have 2 parts to that system. You have a relief valve, which is down on the pump itself, between the discharge of the pump and the intake of the pump. And then you have a pilot valve, or control, on your pump panel. The pump panel controller, the pilot valve, will sense pressure changes and control the discharge relief valve to bypass water from the discharge side of the pump back into the intake. The intake relief valve system, again, has 2 components. Typically, you have a dump valve down on the intake, and you have a pilot valve on the panel or in a compartment on the opposite side of the truck, basically doing the same thing, controlling the intake pressure so that you have a spike on the intake side of the pump. The water will dump to atmosphere to maintain a constant pressure on the intake side of the pump. Main reason you have intake relief valves is you need a pressure differential between intake pressure and discharge pressure for the discharge relief valve system to function. There's got to be a differential so the discharge pressure can bypass back into the intake side of the pump. The intake relief valve also controls or protects against water hammers. If there's a water hammer created on the intake side of the pump, it'll dump that water to atmosphere. Now we're also, when is the single
August 1st.
August 1st. So we are also coming out with a single controlled intake relief valve that doesn't require a pilot valve. It'll be set right on the valve itself. So, good question, Ron.
All right, thanks, Jay. Okay, our question number 4 comes from Ray from Carman, Manitoba. At what temperature does water begin to boil when at 175 psi pump pressure?
Well, and I guess this gets into what we concern ourselves with is water boils actually at a lower temperature when it's under vacuum. So we run into cavitation problems. Of course, in the eye of the impeller, due to the fact we tend to try to run away from the water. If we're trying to pump more water away from the pump than we can supply to the pump. So that leads to cavitation, which in a vacuum is actually going to boil or turn to vapor at a lower temperature than our regular boiling point at regular atmospheric pressure, which is 212 degrees. Under pressure, that temperature raises quite substantially. It actually takes about 375 375 degrees Fahrenheit to boil water at 175 psi. Now we end up having recirculation cavitation issues sometimes, which is on the discharge side of the pump, and that's also under pressure. But what it's doing actually there is creating a negative pressure right at the exit way, the impeller and the stripping edge. So again, it boils the water and causes cavitations.
Great, thanks, Greg. All right, we're going to go on to question number 5. We have a two-part or kind of related question here. So Paul from Brantford, Ontario asks, why are anodes still an option on pumps and not mandatory? In my eyes, it is like selling an engine without an oil filter. And then a related question is from Michael from Howells, Nebraska. He said, some manufacturer reps I have spoken with have stated that with poly tanks and stainless steel plumbing that there is no longer a need for anodes. What is Waterous' position on this?
I'll take it, my turn. I agree with you, Paul. I wouldn't have a pump without an anode on it. The reason I guess they're still optional primarily is because NFPA does not require them. And unless they do, no pump manufacturer is probably going to make them standard. They're a good idea though. As far as the second question goes, it's true that back in the old days when we were using steel tanks and cast iron plumbing, there was a lot of material there that could possibly corrode. Of course, poly tanks have been in use for many, many years. They don't corrode. And also stainless steel plumbing, which has gained in popularity over the last many years, does not corrode either. So what that leaves you with is a cast iron pump in most cases that still can corrode. So it's important, possibly even more important nowadays, to have anodes in your water system if you're using a cast iron bodied pump, which is typical, because all of the corrosion takes place on the cast iron. It's all focused now on the pump. It's not spread amongst the tank and the plumbing as it was in the old days. So good idea to still specify anodes on your fire truck, especially if you have brackish or acidic water in your area.
All right, thanks, Steve. Okay, question number 6 is from Lloyd from Sumner, Washington. Hey, Lloyd! Why, after installing a new packing, it cannot be adjusted to get a dripped rate for cooling? We have to back the gland all the way out and still only getting a drip a minute. We're afraid that the shaft is not being cooled enough.
Okay.
Uh-oh, did we stump the pump, guys?
What's that?
I go ahead. Come on, I can say asbestos.
Do Teflon.
Uh-oh, we have a battle.
Yeah.
We have a battle.
No, basically, one of the issues you're going to have, I guess, is you compress the packing. New packing especially, it's dense, and so when you do compress the packing, if it does get over compressed, it doesn't want to release and come back out. But so by backing it off, you will release and relax the packing gland to allow water to get in between the two interfaces. Do you have anything besides that?
All right, good question, Lloyd. The next question we have is question number 7. Already, nobody has stumped our pump guys yet. Jeremy from Delta, Ohio. What is the optimum size for a tank fill so that refilling the tank will not shut down the pump while pumping?
I guess since I answered the previous one about pump cooling, this one kind of ties in with that. As I mentioned before, most of the time the tank fill is a 2-inch line. Again, even when you're filling the tank from draft, you want to be careful that you don't open that too far. And I think what he's talking about, shutting down the pump, built into the governors, it will realize when you get into a cavitation situation. So it might go down to idle and then it flashes low water at that point. So no different than your discharges. If you're flowing more water than you can get to it, you're going to get a cavitation situation. So it's really tough to answer because not knowing what your source is. If you're from a hydrant, you shouldn't see that, and you got to be careful because a lot of the tanks, the plastic tanks with the baffles, they have a maximum fill pressure also. So not only are you have to worry about putting too much water in there at one time, which will cause cavitation and shut down the pump. We also have to worry about the pressure that's being exerted into the tank when you're filling it. So you have to worry about where your source is coming from and how far you open that valve.
All right, thank you, Greg. We're off to question number 8. Mick from Canastota, New York. What makes the chain case better or worse than a gearbox design? I've been a Waterous fan for a long time. Oh, thanks, Mick. Having worked on most of the major pumps, and Waterous is by far superior. Woo! But I always get asked, why a chain drive? And I've never really had an answer. Who wants to take this one?
I can take that one because I was here when we developed the chain drive transmission back in the 70s. A lot of people don't know, Mick, that really the impetus for getting us to redesign our pump transmission was actually noise. Back in the late 70s is when OSHA started coming out with noise level restrictions for fire apparatus. So we took a look at our part of that fire truck, the pump, and said, what can we do to lower the noise? And of course, most of the noise comes from the engine, right? But we can't control that. So we looked at the pump and we started looking particularly at the transmission because using a gear drive transmission, which is what we used prior to developing the chain drive, you have backlash built into gears. And it has to be there. That's just the way two gears mesh together. So that backlash, especially at lower speeds, sometimes can have a tendency to cause rattling noises and just loud noises coming out of that pump transmission. So there were some automobiles back in the 70s that were using chains for front drive cars, which were just becoming popular at the time. So we took a look at that idea and did some experimenting and put a chain inside the pump transmission. So now we have an involute spline chain that's grabbing onto each sprocket, and there's no backlash there. There's no slop between the chain and the gears. So we found we were able to reduce noise considerably in the pump by going to the chain drive transmission. So that's what really made us take a look at it, and one of the main advantages of using the chain drive. The other, of course, is transfer of power. Again, during that same time period, back in the 70s, that's when diesel engines first started becoming popular in fire apparatus. Prior to that, they were all gasoline engines. And with the heavier duty, more powerful, high torque diesel engines, we thought it was important to make sure that our pump could stand up to those higher torques and higher powers. Now, of course, the pump didn't change. A pump only requires a certain amount of horsepower and torque in order to pump rated capacity. That really hasn't changed. But what did change is the engines now are capable of producing a lot more torque. And there's nothing to prevent the pump operator from increasing the speed and trying to pump 2,500 gallons a minute with a 1,500 GPM pump. So even though it's not required under normal operations, certainly the pump operator could increase the throttle, and the centrifugal pump will absorb every bit of horsepower that engine can put into it. So we thought it was important to overbuild the pump transmission and make sure it could withstand that. And we found from testing that because of the engagement of the chain with the sprockets, as opposed to two gears meshing together, the load being transmitted from the engine to the pump is now being spread over more teeth on that sprocket because the sprocket is engaging with more teeth on the chain. So by dispersing that load on the gears throughout more of the gear face, we found that it was able to handle more power. So it's more efficient and it's quieter is the quick answer to your two questions.
Keep in mind that we do use ATF in the chain case as opposed to the gear cases. A little bit different on there with the ATF because it is a thinner lubricant. It allows that lubricant to get in between the sprocket and the chain parts there. So make sure that you are checking the serial number and the pump that you have through our website and finding out which lubricant it does use.
All right, so great. I mean, you can't teach that kind of knowledge, people. Question number 9, we have Ed from Ishpeming, Michigan. We better let Jay handle this one. We've got, he's from Michigan. Wondering about the hydrant pressure when opening the intake valve, if the pump is in idle or in RPM pressure mode. Does it harm the pump in any way in any of the positions?
Well, you typically are going, when, I guess your question,
I think they're talking about a governor there, whether you're in RPM mode or in pressure mode.
Yes, okay, that makes sense. All right, I was trying to think of how our pump would or system would matter there. But yeah, I mean, you typically are changing over at idle or injecting the at idle. And as far as the RPM and pressure mode, actually would probably be, Greg probably would be a better.
Yeah, if you're in RPM mode, basically it's gonna, as you open up the hydrant, let's say you're switching from tank to pump over to hydrant, it's gonna maintain that same RPM speed, and what's gonna happen is you're gonna get a higher pressure. You have to take the pressure that you're operating at from tank and add your incoming pressure, which would be the hydrant pressure. If you have it pressure mode, that's where your safety is gonna come in, because it's gonna recognize that the pressure is increasing, and it's going to reduce the RPM or the engine speed to maintain that pressure that you have it set at in the pressure mode. So as far as harming the pump, I don't, in either one of those, I think we're worried more about the pressure that's going out to the hand lines. So if you're in RPM mode, you need to take that into consideration if you're bringing in hydrant pressure, because again, it's going to add that hydrant pressure to your current discharge pressure. So typically you want to be in that pressure mode so that it has the reaction, slows the engine down at that point. I can't think of any, I mean the engine, the pump really isn't going to see, unless you're on a really hot hydrant, it's not going to see any issues with pressure.
The only other consideration would be water hammer. If you have a fairly hot hydrant and you open the valve quickly to allow water to enter the pump, there could be a water hammer situation taking place there, but NFPA has addressed that, and they do have a requirement for a slow open, slow close valve at that hydrant connection. So that should be taken care of. You shouldn't be able to override that. The other thing a lot of people maybe don't know is that we manufacture hydrants here at Waterous Company. That's actually a large part of our business, and I quite often get the question, why does it take 19 or 20 or 21 turns to open that hydrant? It seems ridiculous, and the reason for that is simple. It prevents you from opening it too fast and creating a water hammer. And NFPA has put the same type of restrictions on the fire apparatus, where they have a requirement for a slow open intake valve.
I'd like to add, we're not the hydrant experts, but we know the hydrant experts.
We know hydrants.
All right, I want to apologize. We're not in our main studio, so if we're not as loud as we normally are on these videos, I apologize, and we're going to have everybody speak a little bit louder. The next question we have here is from Tyler, Lewiston, Montana, and this is a long one, so hopefully I can read the full thing. I've seen a few pumpers that are equipped with PTO-driven midship pumps capable of 1250 GPM. I see advantages of this being the simplicity of putting the pump in gear. I would question the mechanical stoutness of a PTO compared to using the truck transmission. My question is, has there been any issues reported with using these PTO-driven fire pumps specifically in 1250 or 1500 GPM range?
This being more of an application question there, I'll kind of take that as I had some time in the applications department. Yeah, early on, it's kind of a two-part question there. It does help that we don't have a shifting collar that we're using, so it does help in a shifting situation. A lot of our shift issues were taken care of with the help of the Allison Myo 9 standards, which if the OEM wired that in, it actually recognizes a butt tooth condition and you don't have a completed pump shift, and will actually jog the drive line to help it engage. But so that is one thing. It does help with putting the pump in gear as you are just engaging a PTO, which is a hydraulic actuation of the power takeoff. Answering the questions, yeah, and early on, the power takeoffs that were available both from Muncie and from Chelsea, we had problems with overloading those or over-torquing those. And you could run into problems if because a pump, as Steve had mentioned before, you know, the horsepower, if we've got plenty of horsepower in the engines that we have nowadays, and if you supply a pump with horsepower and the water, you know, we can pump it a lot higher than the actual rating. So we run into issues sometimes where we can over torque the power takeoff, but some of the OEMs, they have been able to tie in a speed limiter or a cutout or a limiting device, and that they actually wire it in so that we don't overspeed the PTO. But power takeoffs have gotten more robust. Also, the where they're mounted on the transmissions and the ability to take torque off, we can run pumps up to 1,500 gallons per minute now off the power takeoffs, and they have the ability to handle that torque and those speeds.
Perfect. Thanks, Greg. All right, so we're going to move on to question 11. Robert from Lincoln, Nebraska. He asks, why do you now have a 1/4-inch vent hole in the tank to pump check valve? If the tank to pump valve is closed, it has nowhere to go. Doesn't the temp protection valve do the same thing? Can we spec a check valve with no hole?
That vent, basically, I think it's about an 1/8 inch hole that's drilled into it typically, but basically that hole is there if you're operating off your tank and you're flowing hand lines and you shut the hand lines down. Water has been coming in from the tank through the tank to pump valve, pushing the check valve open, dropping into the pump. The check valve is there so that if you charge from a hydrant, basically, you don't shut your tank to pump valve, the check valve will close to seal off so you don't overpressurize or push a lot of water up into your tank, possibly damaging your tank. What the hole is for is if you're operating off the tank, water's coming into your pump, you're discharging it, and you shut down your discharges, the check valve will close because there's no more water coming in from your tank. And now you just created a sealed vessel, right? And there's no place for the pressure inside the pump to expand to. So as you start to overheat the pump, you basically, you're right, as far as an overheat protection manager would probably go off and blow that out of there. But if you don't have one, that's what the hole in the check valve is for. It allows the pressure inside the pump to feed back up into your tank. And you also are correct, if you shut your tank to pump valve, obviously that hole in the check valve won't help you. But as far as the check valve and having a hole in it, all of our check valves do come with that hole. It's used to be mandatory by NFPA. They did change it or put it into the annex in the back, just stating what that hole in the check valve is for. But it's a safety issue, basically. That's why it's there.
It's one thing to keep in mind, though, with the operators, because occasionally we will get the question, hey, my tank fill is closed, my pump cooling line is closed, and my tank continues to overflow. So a lot of times they may look at their tank fill valve, possibly having a leak, You got to remember, even at an 1/8 inch hole at 150 psi, that's allowing 10 GPM roughly to go back into the tank. So it will overfill the tank, which can be a problem up in our northern climates where it freezes up by where the pump operator stands. But it is a place that it's going to continue to backfill, especially if you have your tank to pump valve open. Now, typically, I instruct operators on my own department to leave that tank to pump valve open, because if your hydrant pressure was to drop or you lose that hydrant pressure, it would automatically start taking it from the tank. So.
I think one more point to make, and he didn't actually ask this, but it's important to understand too that the hole that's in that check valve does not act as a pump cooler. And I know that wasn't your question, but it's there, as Jay mentioned, just to relieve pressure, because as water heats up, if you're deadheading the pump, the water starts to heat up. Like anything else, it expands, and you have to give it a place to go. And that hole in the check valve is where it goes. Not much water flows through that check valve under those circumstances. Very little water actually flows through there, but it creates an opening so that the pump doesn't overpressurize. We have done some tests, and we without that check valve in place, and the water that's expanding in there as it gets hot, and especially if it starts to boil and converts to steam, will find an opening. It'll make an opening. It'll blow the packing out of the pump. It'll blow the mechanical seal out of the pump. It may blow that nice 6-inch chrome cap off of the suction. It's a force that needs to be dealt with. So that's why the hole is there, but it does not serve to cool the pump. Even with that hole there, the water inside the pump can boil. So that's why it's important to also have an overheat protection device on there as well.
All right, way to share. Everybody got a part of that question. All right, we're gonna go on to question number 12. My favorite number, but this looks like a long one again, so bear with me. Mark from Queen Valley, Arizona. Every 5 years, we have to tear down the pump and remove all hard water deposits from the pump housing and shaft. Since the last cleaning, we left the pump in dry mode, no water in the pump. It now has a constant drip from the packing again. The department runs under 200 calls per year. The last time it had the graphite packing installed, new packing nut, threads and collars. They all need to be replaced again. Packing is as hard as a rock and will not tighten. Question, how can we stop this buildup?
Well, I can answer, I guess, part of it as far as why the packing would possibly start leaking or leak more. When you are leaving a pump dry, especially if you're leaving it for extended periods, the packing will dry out. Right? You need that moisture in there to keep the packing lubricated and basically swollen. I know Arizona, that area of the country, New Mexico, Texas, those areas have very hard water. We used to have to run special seals and stuff in Arizona because of how detrimental the water was out there. So as far as the packing, that may be part of it. You're kind of a plus and a minus. If you don't have, if you leave water completely full of water all the time, you have the calcium in the water, and it builds up on the inside of the pump, on the shaft, and it sounds like that's what you've been cleaning up. Not running them, having water in the pump can dry out the packing and can cause problems there. As far as questions how to stop the buildup, I'm not sure if there's really anything besides using the pump. I mean, that's
the more you can use the pump and keep that lime deposits, calcium deposits, or whatever it is in there from building up is to continually use the pump. And unfortunately, at 200 calls per year, that's not enough. So, at least in your case, so important to run the pump when you come down there for your monthly drills or monthly meetings, or hopefully weekly drills and meetings. The more you can run it, the better. Other than that, there's really no answer to stopping that buildup. There are additives that are sold that can be added to the tank to help condition the water. I don't have a lot of experience with those. They may work, they may not. But if you haven't tried some of those products, it might be a good thing to try.
All right. Thank you for that question, Mark. Up to question 13. Joe from Hudson, Ohio. He asks, with a 1500 GPM pump, drafting out of a dump tank with 6-inch hard suction, 5-inch adapter connection to a low-level strainer flowing 500 GPM through attack lines, all on level ground, how many GPM can we draft to continue the attack and refill the tank on the engine?
This is, I'll take a stab at this one, a little more applications also. So there's a couple of things that come into play when we're drafting. Versus a 1,500 gallon per minute rated pump, we rate that same pump a lot of times up to 2,000 or 2,250 gallons per minute. Problem is, at those higher ratings, you need more than one hose. So in this case, we have a 6-inch hard suction. It depends on your altitude, number one, and also the lift. That 1,500 gallon per minute pump is capable of doing a 10-foot lift up to an altitude of 2,000 foot. So if you're at sea level, you're only doing from a drop tank on level ground, you're only doing a 3.5, 4 foot lift possibly. You should be able to pump in excess of 1,700, probably close to 1,750 gallons per minute if you did not have a butterfly valve. So if you have a butterfly valve, that's going to be an added friction loss into addition with the low level strainer. But you're capable of getting up to that range. You shouldn't have any problem doing 1,500 through that strainer, and especially without a butterfly valve. Anything to add?
All right. Thank you, Joe, for that question. Question number 14. Nobody's stumped the pump guys yet. But Daniel, he's got a good question here. Aberdeen, South Dakota. What should I do between tests to keep my fire pump in good shape?
Same thing as there's a couple of different things. First one is general maintenance as far as checking, as far as fluids, that type of thing, chain case, that type of thing. Big thing though, just like with the situation we had in Arizona with the calcium builds up and that kind of stuff, use the pump. Needs to be exercised. Pumps fail far more often from lack of use than they do from overuse. Very hard to wear a pump out. But if you're not using it, you're going to create problems. So that really, use is the main thing that I can think of to keep a pump in good working order.
And not just the pump, but the accessories.
Accessories, right, especially.
A lot of times it's the discharge valves that start sticking. It's the relief valve that doesn't want to relieve anymore. Those type of devices. So the more you can use those, the better. And again, if you can get into a weekly or at least a monthly checkout of the truck and operate all those accessories, especially, it's always the valves that never get used, right? The pre-connected lines seem to be fine, but it's that rear 2.5 that hardly ever gets used that all of a sudden is difficult to open because it hasn't been open for 6 months. So use it is the answer to your question.
I've got one to add, and this actually happened on my own department recently. Here we did got our annual service test done to the pump, and when they first actuated the priming pump, it wasn't able to pull the prime that it should be able to, or the vacuum that it should be able to. In our area, we don't have corrosion issues as much as buildups, similar to what was brought up before, and you can have the same problem in that aluminum, basically aluminum coated rotor that we have, and the vanes sticking in there where they're not expanding all the way out. So if I only have 3 of the 4 vanes that are working, you're not going to have the performance of that primer. So the biggest thing is, like we brought up, exercising that. And shame on me, it's my own department. I didn't have it on the truck sheet to exercise the priming pump. So just running that, it's one of the things with the biodegradable lubricants that are out there. One that we use called the Prime Safe. You should exercise that because it's designed to break down after, like it's designed to be biodegradable, and that can become sticky as it dries out. So it's a good idea when you're doing your truck checks just to run it, purge a little water through there, which flushes out your impurities, your buildups that we would have, and then possibly some of that biodegradable lubricant.
Yeah, there's no problem with that in the tank, but as soon as it gets down into the pump and it's exposed to water and air, and it's going to break down. That's what happens. It needs to be run.
All right. Good question there. All right, next question. We've got question number 15 already. And I apologize if I mispronounce this name. Hulon, Spartanburg, South Carolina. If a fire apparatus manufacturer were to build a truck with an electric motor for the engine, what type of pump drivetrain would be most efficient?
Well, I guess this ties into the release of the electronic apparatus, if you will. There's electronic cars out there. I guess the next thing would be to go to the electric fire apparatus, and I don't know a whole lot of those, whether we have a similar drive line in a transmission that we currently have, but or whether they'd have a power takeoff. But if they do have a drive line, we could continue to use a split shaft drive. That electric motor would then drive the pump just like it does with our diesel. If they have some type of power takeoff, we're still probably going to need a speed increaser, but if the electric motor is able to put out enough output fast enough with your horsepower and torque, then you would not need a speed increaser, and you could go with a direct drive pump. But there's a lot to learn yet with those in those pumps that are there, but we can do PTO driven pumps if it would be an output like that, where it would be electric motor driven, where you'd have a separate motor, or if you could still do a split shaft drive, we would operate it the same way.
I'm not sure where that question was going exactly, but if you were talking about possibly using hydraulic drive, a hydraulic motor to drive the pump that would be powered by an electric engine in the fire truck, that's maybe a possibility as well. However, you talk about efficiency, and a mechanical drive line is still the most efficient way to transfer power as opposed to hydraulics. So I don't see that changing. Perhaps, again, depending on the speed that the electric engine would operate at and the amount of torque it's able to put out, possibly it opens the door for more PTO applications as opposed to split shaft. But bottom line is the pump doesn't know or care, for that matter, where the power is coming from. We actually test pumps here in our test room with electric motors. So not much difference as far as the pump is concerned. It just needs power and it needs speed in order to do its job.
All right, thank you. Jim, no city or state provided. Is that you, Jim Fazekas? Can you fill your tank water through a discharge on the pump?
Well, Greg talked about that already. That's what we would call the tank fill valve, which is installed by the truck builder. It's a valve that comes right from the discharge manifold of the pump to the control panel, so you can open or close it, and then back into the tank to fill it. Not sure exactly what that question means. That a lot of apparatus being built nowadays have what they call a direct tank fill, which is an inlet on the pump panel or somewhere on the vehicle that leads directly into the tank, which would have to be connected to a pressurized water source in order to fill the tank. I've never heard of anybody doing it, but I guess you could connect a hose from the discharge outlet on the pump to that direct tank fill pipe and fill it that way. But every fire truck that I've ever seen has got a tank fill valve for that purpose.
Well, I tried to trick you guys here because there's a second part. So secondly, when working with a fire and the first engine runs out of water, can you hook the second engine supply line into a discharge of the first engine? then pump the second engine through the first engine to supply enough water to fill the first engine's tank and keep the hand line working. I've done this on vehicle fires on the interstate. I've had senior engine operators tell me that it can't be done as we are physically doing it.
I guess, you know, it's going to depend on the size hose that you can use that first engine as a manifold. You're not going to want the pump engaged at that point if you're coming in through the discharge side. I would typically go in through the intake side and relay it to them, but you could use it as a manifold. You got to make sure that the hose that you're supplying it into that discharge with, and again, that pump has to be disengaged because it's going to try to push that water back out to that. But it could be done. Again, you're limited by the size hose that you're using. So your question, could you supply that hand line and then also fill the tank? You know, if you've got an 1.5 inch, 1 3/4 hand line that you're operating, and you've got a 2-inch tank fill, 2.5 from the other truck is probably going to be able to handle that. But you wouldn't be able to run both, of course, if you're only stretching an 1 3/4 hose from the second engine at that point.
Another thing that could come into play here is if that particular discharge that you're trying to connect to is foam or CAFS capable, it will have a check valve in there that may prevent you from doing what you're trying to do. So it may vary from truck to truck, but in general, Greg, I think you're right, but it gets a little more complicated when you're dealing with a discharge that's foam capable or CAFS capable.
All right. We do have a final question for the day. We're getting close to the end here. And the final question is actually, they're asking for Jay Rott. Jay, this is a question from Steve, Little Canada, Minnesota. What type of packing was used in 1948 when you started working for Waters?
Oh, thanks, Steve. Appreciate that. Well, it probably wasn't leather at that point. It's probably going back to the asbestos rope packing. So Steve gives me a hard time on my pump classes that I give the generations for all the different types of packing that are used. So, and Steve, thank you for putting that in there.
Of course, there's an inside joke there, but in all reality, we still do get that question today. Yeah. You know, generally speaking, it's from people that are restoring older apparatus, but for some reason, I guess by default, because I've been here the longest, I'm kind of the historian here at Waterous, and it kind of amazes people at sometimes to know that we have records going back to the early 1900s, even the very late 1800s on products that we made, and a lot of times with photos to accompany them. So we do take record keeping pretty seriously here at Waterous, and if anybody's out there that has some of these older applications and are looking for information, call Jay, and he will help you out.
Yeah, definitely.
All right. Well, thank you everyone for submitting your questions. Keep the questions coming, and we'll have round 2 of Stump the Pump Guys in the near future. In the meantime, if you need more information about Waterous, please visit our website at www.waterousco.com. Thanks again, and goodbye.
Thanks.
Thanks, everybody.
Bye.
Have a good one.